So now in this video, we're going to talk quickly about the motivation of this video, I should say, is picking a resistor. And so that's one of the decisions you got to make when you're designing your own circuit. When you're building one from a schematic, usually, hopefully you have the part number they recommend, the resistor value, and you can just use it. Generally, they all use quarter-watt resistors unless it says differently, and quarter-watt resistors are the most common one. So I have two quarter-watt resistors on the breadboard power supply rail right there, and we have 5 volts right here. First thing we're going to do is take a look at the thermal image of these two resistors. So top one's 100 ohms, bottom one's 220 ohms. They both have 5 volts across them. They're not influencing each other in any way. And right now they're both got power across them. It's going to take things kind of settle there. But there you can see the top resistor is a lot hotter than the bottom resistor. And so that's because it has less resistance. It's passing more current because they have the same voltage across them. About twice as much. To make the math easy, I'm just going to kind of pretend like this is a 200 ohm resistor. But it's actually slightly higher, so it's letting through a little less current than 200 ohms, and it's getting a little less hot than 200 ohms. So the resistors, as I said, are rated for a quarter watt, and we got 5 volts divided by 100 ohms of resistance. That gives us our current in amps. So that's 0.05 amps, 50 milliamps. But we take that 0.05 amps and multiply it by the voltage across the resistor to get the power that it is creating and thus has to dissipate, which is 0.25 watts. And that's its rated value, a quarter watt. You actually want to stay about halfway below that wattage, so 1/8 of a watt. 200 ohms of resistance gives you 1/8 of a watt of power. And so that's what the resistor is directly across the rail. And I've done videos where I talk about the voltage being taken off the resistor either as a voltage divider or while it's protecting an LED or other component. And so this is kind of worst case scenario with a 5 volt power supply. 100 ohm resistor will work, but probably 220 ohm resistor will be better because it won't get as hot. And so you'll just have to look at the current that will provide, make sure it's enough current, and come up with other ideas. So now, if you need more current or whatever, now you can go higher with the resistor, and that just is safer in almost every case, unless for some reason a lower current and one part of their circuit raises it in another. But right now we're just looking at protecting the resistor itself, because that's one of the main factors you have to start with. So you can start with your minimum, probably 220 ohms for 5 volts, and work your way up. So now, unfortunately, if it's 10 volts, you really got to do the math. You can't just double the resistance. With 10 volts for a quarter watt, it is actually 400 ohms of resistance directly across the 10 volts directly across it. You would need 800 ohms of resistance with 10 volts directly across it for 1/8 of a watt. And so it's not linear. Twice the voltage does not result in twice the resistance when it comes to wattage. It actually goes up a lot more. And so it's important you do that math, but now we have the baseline for 5 volts that absolute minimum is 100 ohms, but you should probably be about 200 ohms or more, and that's with the 5 volts directly across it. Other components are going to absorb some of the voltage either by its resistance and or its voltage drop. So that's topics for other videos. I'm keeping this one short. So hopefully that helped you. This is the minimum value, and you can work your way up. It's probably safe at any time to use higher resistance. It may not be safe to use lower resistance. So figure out your minimum, and then you don't have to worry about it anymore. You know the minimum now for 5 volts, 100 ohms, and better off 200 ohms. So thanks for watching. I will see you in the next video.